We're going to do an inverse Laplace transform, and we're going to do an inverse Laplace transform involving an exponential, which means we're going to be using line 5 on our table. And line 5 is a tricky little line to learn how to deal with. And once we've learned how to deal with it, it's not going to be so bad anymore. So here's an example. If we didn't have the exponential in here, what would we do? We would see if we could factor the denominator. If we can factor it, we do partial fractions. If we can't factor it, we complete the square. In this case, we can factor that. So we will proceed as if the exponential is not even there and just pull it out. We will factor this. This looks like s plus 2 times s minus 1. And so we have factored it. The next thing we would do is a partial fraction decomposition after factoring it. So that partial fraction decomposition is going to look like 1 over s plus 2 times s minus 1 is a over s plus 2 plus b over s minus 1. Multiply through by that common denominator, and we have 1 equals a times s minus 1 plus b times s plus 2. With these nice linear factors on the partial fractions, we can end up just picking some values of s to make things work. So if I pick s equals 1, for example, this term gets zeroed out. This looks like 3b equals 1. So b is 1/3. If I pick s equals minus 2, this term gets zeroed out. I have negative 3a equals 1. So a is negative 1/3. So now what do we have? We have capital Y is e to the minus 2s. And with our partial fraction decomposition, we have a negative 1/3 times 1 over s plus 2 plus 1/3 times 1 over s minus 1. We have something that is now ready for the table. Well, we got that exponential still there, but the rest of this is something we could invert with the table, the exponential line on the table, whatever line that is. So we go ahead and do it. We say y of t, and this exponential is going to become u of t minus 2. It becomes a step function, u of t minus 2. And then the inverse is 1/3. 1 over s plus 2 inverts to e to the minus 2t. Now this is where line 5 kicks in, right? It kicks in on the exponential, becomes the step function, but also instead of e to the minus 2t, which is what this would invert to normally, we replace the t with a t minus 2. So it's e to the minus 2, t minus 2. And then we have a plus 1/3, and this would invert, this here would invert to e to the t, e to the positive t. So we replace that t with t minus 2, so e to the t minus 2. And we have our inverse Laplace transform. The thing to remember is that the exponential can be thought of as turning into the step function, and then you do the rest of the inverse normally, but at the end, take all your t's and replace them with t minus 2 or t minus a in a different problem.